Proceed. Okay. So good afternoon, everybody. So I'm Alfredo Egidio. I'm going to present, to introduce our first speaker is Abraham Hernandez Pacheco. He's working on pensions and is working with me and Agnieszka doing her PhD around the calculation of ruin probabilities for optimizing pension fund investments, and that's the topic of his talk of today. I will let him to introduce himself, and he can start if you like. Thank you. Abraham, you can start.
Thank you, Alfredo. Thank you very much to the organizers. And yes, I will present our work on using probabilities of ruin to optimize a pensions investment portfolio. Pension funds and our retirement assets add to around 40 trillion US dollars, which is almost half of global GDP. So we're talking about a lot of money having to take these kind of decisions. And variations in asset values is arguably the most significant component in the determination of the probability of ruin of a pension fund. That is, of the possibility of the fund to pay for all its liabilities. And then also changes in interest rates and other economic variables affect both assets and the liability and the present value of liabilities of a pension fund. So the decisions for the asset allocation of the pension fund is not only about the total return of the investments, but also the difference or the ratio between assets and liabilities. And this is what it's usually referred to as asset liability management, or ALM. ALM techniques typically rely on very complex financial models, which usually do not have closed solutions. So they must be solved numerically through simulations. And usually, to determine this optimal asset allocation, most models use or have to make some assumption about the risk preferences or the utility function of the sponsor. Then the probability of ruin has been usually used for non-life insurance programs, as it was originally defined by Lundberg in 1903, and there has been a lot of work around this. And it has been also used as a measure of solvency for pension plans by several authors more recently. And what we are doing is using it not only as a solvency measure to calculate the probability of ruin, but using this probability as the measure to optimize the investments. So we will be looking at the combination of assets that minimizes the probability of ruin of the pension plan. So that is what this is about. So we start with a defined benefit pension plan, where let's say that the pension will be 1% of salaries per year of service. So if you have 30 years of service, you will have a pension of 30%. And then these are the usual measures for, the actuarial present value of liabilities. Then we have the actuarial present value of salaries, which we will later use. And the PBO, which is the present benefit obligation, as referred to in on accounting standards, which is the typical measurement of liabilities from the financial point of view, and what is recorded on balance sheets and income statements, etc. And then we want to have contributions as a constant proportion of salaries. So we solve this, this equation. We have the liabilities, the present value of liabilities, calculated at the expected long-term rate of return, that is R. And then from those liabilities, we deduct what we already have, the fund at time 0, and we divide that by the actuarial present value of salaries, also calculated at this rate of R. And the present benefit obligation has to be calculated every year at the rate of long-term high-quality bonds. We will call that C. And usually, the rate that we are expecting to invest the funds is larger than the rate of high-quality corporate bonds. Why? Because we assume that we will be able to invest this long-term on, say, equity or riskier bonds and have a better return. So that is the typical assumption of a pension plan. And this inequality has to be taken into account. What it means is that if we invest the fund at high quality corporate bonds, we will not have enough. We will not have enough funds. We have to invest them at a higher rate. Then we will look at the fund. So we will, at this point, we will only consider two assets, which is this high rate corporate bonds and the stock market. So a proportion alpha of the fund is invested in the stock market and the rest in long-term corporate bonds. And we have here on this timeline, we have the initial fund, CO, C1, C2, etc. are the contributions as already defined. Then here we have the payment of pensions, P0, P1, P2, etc. These are the payments. And we have at during each year, which was the return for the corporate bonds and which was the return for the stock market. So FT, which is the fund at time T, is given as FT minus 1 plus contributions minus pensions. We are assuming all this paid at the beginning of the year, just for easiness of doing calculations. And then that we multiplied by 1 plus alpha times the return of the market plus 1 minus alpha, the return of the corporate bonds. And we are assuming no shorts, so alpha is between 0 and 1. So no shorts investments. And the main concern is the funding ratio. And this is the fund divided by the present benefit obligation at each year. And if FR goes below certain level, the sponsor needs to make additional contributions or benefits need to be reduced. This is usually either by legislation or by the plan bylaws that say that, I mean, if money is running out, you need to contribute more or lower the benefits. And as I explained, investing everything in bonds would not be a solution. That would mean we will not have enough money at some time. And then we will say that the plan faces ruin anytime the funding ratio is less than beta, right? So let's say 60% or 50%. This is, again, usually defined on legislation or the plan's bylaws. And we will define T as or T alpha, alpha being the proportion invested on the stock market. So T alpha will be the minimum T where FR is less than beta. For T equals 1, 2, 3, this is on, performed every year rather than on a continuous basis. And then T alpha is infinite if FR of T is greater than beta for all T's integers. And then the probability of ruin is defined by phi alpha as the probability of T alpha being less than infinity. So that is going below beta at some time. So this is not the classical Kramer-Lundberg situation for a non-life insurance program, but and for this, I mean, this Kramer-Lundberg situation has been studied, and there are some even some closed some closed models and formulas to obtain the probability of ruin. This is not the case, but we can find through simulations the alpha that minimizes this probability of ruin. So this is an example for an initial group of almost 700 participants with different ages, different years of service, etc., with some retirees already in the plan, and an initial funding ratio of 73%. And what we want to avoid is the plan going below a funding ratio of 60%. Then on the right, we see the historical returns for the Standard & Poor's 500 and the how the corporate bonds vary from one year to another. And then we have the time series and a scatter plot of these two, where we do find some correlation. I mean, they are not independent. That is economic theory would argue in favor of this not being independent variables. So we use copulas to simulate, to model and then to simulate the returns of the stock market and the change in corporate bonds. And remember, the change in corporate bonds times the duration of the portfolio explains the return of the portfolio in these investments. So well, we modeled this with a Gaussian copula with a kernel distribution estimates. So we use the observed distribution of these returns as the distribution for the marginals of the copula. And as you can see, I mean, it's certainly not a perfect fit, but seems to be a good enough fit. So we use this model. Now we look at these graphs. This one shows the PBO, how if the corporate rate the corporate bonds rate does not change, if it remains constant at a 3%, then this is how the PBO evolves, right? And the group is big enough such that mortality doesn't make much difference. I mean, we don't have like big changes because of mortality. And then this is how the fund will look like if it is invested at a constant rate of 5%. So at some point, it's equal, and we're able to pay all liabilities. Then, of course, the corporate, the rate of corporate bonds does vary. So this is how it looks like. This is this red line. So it varies when corporate rates go up, the present value comes down, and if it goes down, the rate, the present value goes up. And then here is what happens if we invest everything in corporate bonds. Well, eventually, of course, it will not be enough, and at some point it reaches this level of 60%, so we face ruin. At that time, of course, the plans will not wait until the funds are zero, but at that time it must do something, which is usually very painful for the sponsor to put more money, or for the retirees or the participants to have a lower pension. And then what happens if we invest everything on the stock market? Well, it might be enough on the long term, but at some point here, we reach, again, the ruin. And at that time, we cannot say, okay, we'll eventually recover. At that time, something needs to be done. So that, again, is what we try to avoid. So we perform, this is the general outline of what we do. So we first simulate the survivorship of participants until the extinction of the group. Then we simulate the market returns and the corporate bonds change and returns. So we simulate the returns, we build the returns from the simulations, calculate every year the present benefit obligation, calculate the fund for each year, and this for each alpha. So we calculate the fund assuming an alpha of 0, 5%, 10%, all the way to 100%. And
it's almost time.
Yes, just a couple more slides. So, and we calculate ruin if we reach below 60%. So we repeat this 500 times, and here are the results. We estimate the probability of ruin for each alpha, and we find that it's at 60% of investment in the stock market that we have the minimum probability of ruin. And well, we perform this for different initial values of funding ratio, and it's very consistent. Then we perform this for different assumed long-term rate of returns. We do have different, here we have some changes, but the idea is the same. And well, we're still working on this to these simulations with increases in salaries and pensions, using stochastic mortality, model more asset classes, not only the stock market and corporate bonds, a dynamic optimization of alpha, different values for beta, and different models to simulate financial series. So these questions are the ones that will be addressed on my thesis on this issue. So thank you very much.
Thank you, Abraham. I don't know if anyone would like to ask some questions. I don't have any questions in the chat. But I might ask you a question myself. When you set the calculation of the pension as a percentage, let's say 1 or 2% over the salary times the number of years of payments, then what's the unit of the pension? So the pension is a unit of pension per year?
Yes, 1%. Say if you have a salary of 1,000 and you have 25 years of service, that will be 25% of that 1,000. So you will have a pension of 250.
And that's an annual pension, right?
That is an annual pension, yes, that remains constant
over time.
I'm not assuming that it increases with inflation or anything.
No, so this is all based on expectations. Yes. Okay. Thank you. Any further questions you'd like to ask? Anyone? I have another question, if you don't mind. Can I?
Please.
When you set up it's quite interesting the model you've used, because people is probably not aware the ruin model that you are using. It's, even though you have addressed it and you have mentioned the Kramer-Lundberg model, risk model, it's quite different from your own model, and it's the idea. You can say that the idea is similar, but the model is completely different, because the Kramer-Lundberg model was built for non-life insurance, and pensions, even though it's dealt by actuaries and inside insurance programs, it's not an insurance. I mean, it's a different thing, and so I would like you to say something about the ability to use this model, and how different, and where did you get it from?
Sure. I mean, I only put the Kramer-Lundberg model as a reference. In fact, I don't use properly the Kramer-Lundberg model, since, as you say, I mean, the model assumes a series of independent random variables over time. This is certainly, in the case of pensions, not the case. They are not independent, and it's not stationary. I mean, these are payments that go down. Well, first go up because you have more retirees, and then they start dying, and eventually they reach zero, etc. So I am using the model just as a reference of the probability of ruin, and that it has been used in insurance. But what I'm using is the concept of the probability of ruin rather than the Kramer-Lundberg model. And then I'm building upon that. It has been used to measure the solvency of pension plans, the probability of ruin, but I have not seen it used as the objective function to optimize the asset allocation of a pension fund. So I would say this is a new idea that is based upon these general ideas of probability of ruin and what has been worked along this.
Okay, thank you very much. It's now time for, thank you very much, Abraham, for your nice presentations and explanations. It's now time for the next speaker.
Okay. Okay, thank you, Abraham, for a nice talk. And our second younger speaker is Silvia Oliveira. She has a joint work with Alexandra Moura and Carlos Oliveira from ISEG. Please, Silvia, you have 20 minutes to present your work. Thank you.
Thank you. Hello, good afternoon. So my name is Silvia Oliveira, and my supervisors are Alexandra Moura and Oliveira, and I am studying mathematical finance at ISEG. And I will talk about the role of insurance in investment strategies. So the real options study investment decisions and have main characteristics. First, the investments are irreversible because of the costs. Other characteristic is the uncertainty of the returns and the possibility to wait. And the insurance, it's really often used to mitigate risk and also has a big impact on a company's investment strategy. Therefore, we thought it would be really interesting to approach this subject because there are a lot of investment strategies and we want to know how the insurance has impact in it. So it was considered an investment model from the point of view of a company. This is our baseline model. As you can see, we start with this equation and then we arrive to this simple one. So here we have two sources of uncertainty. We have the company's future revenue, which depends on a random economic indicator and follows a geometric Brownian motion. The state process X evolves according to a stochastic differential equation, as you can see here. And there are also unexpected adverse events that reduces the company's future revenues. The times of occurrence of such events and the severity in the revenue reduction are both random, and such events were modeled by means of a compound Poisson processes. So we have a functional here which represents the expected value of the company given a certain decision. And this problem is solved in a stochastic environment because some of its elements are stochastic processes. Here we have a functional that it is written in an integral form. So we use the conditional expectation and the strong Markov property of the GBM and of the Poisson to arrive to this simplification, which is a functional with a terminal value. So the U is the absolute percentage lost value in each occurrence. The FU is a function of indirect costs. R is the interest rates, and I is the sunk cost. So to solve this problem, we use the dynamic principal approach. Basically, this derives in the Hamilton-Jacobi-Bellman equation, which is represented here. And to solve the problem, we need to solve this equation. As you can see, we have two parts here. In this first part, we have L, which is an infinitesimal generator, which defines the full process of X. And LV is an Euler-Cauchy equation. And the solution for this equation is well known. And it is a general solution. So we have two regions, the continuation region and the stopping region. I just talk about this part of the AGB equation. And when the solution comes from here, basically we are in the continuation region. That means that we do not invest. We need to wait until investment. And the other parts of the AGB equation is that one. When the solution comes from here, the value function is in the stopping region, so it is good to invest. So now we know that the investment decision is made in the stopping region. Here is the value function that is given by this part is the solution when we are in the continuation region, and this terminal value when the stopping region. So to solve this system, we need to make sure that the value function is continuous and differentiable. So we use some smooth best conditions to solve it, and the solution is given A and X star. A is a parameter and X star is the threshold of the revenue. So now the company knows when should or not invest. In these kinds of problems, optimization problems, it is really common to make the comparative statics. Basically, it is how the strategy of the company changes if we fix all the parameters and change just one. So we decided to make it for the volatility and the drift of the GBM and for the intensity of the Poisson. Something unusual happened here actually, because here the threshold, it's not monotone with the drift, and usually what happens in that kind of problems is that the threshold decreases with the drift. So usually the company decides to anticipate the investment. But in this case, we still figuring out the behavior of the company, because the threshold first decreases and then it increases. So maybe it could mean that the firm has higher expectations about the profits in the future. So maybe he wants to postpone the decision of the investment. But yeah, we're still figuring out that. And the threshold increases with the market's volatility. And therefore, the investment decision is postponed if the volatility increases. The same happens with the intensity of the Poisson process. There is an increase in the average number of occurrences, and thus the investment decision is also postponed. So here we have the model with insurance. In this case, the optimization is done in the same way. But this time, we also want to optimize in relation with the insurance strategy. As you can see, we also simply have a simplification of the first equation using the conditional expectation and the strong Markov property of the GBM and the Poisson. And we arrive to this terminal value. So here we have different elements, like DU is the risk retained by the company. The FZU are the function of the indirect costs. It is a measure of risk. It is related with the insurance because if a company has insurance and something happens like an accident or breaks a machine or something, there are some, of course, it will receive some of the money of that, but there are some indirect costs that are not taken into account. And we also have here alpha C, which is the loading. When the insurer measures the risk, it does like the expected value, which is the pure premium, and then it adds something to gain from it, and that is the alpha C, and it defines the premium principle. It could be like the variance or the standard deviation. So here we have this V, which is the supremum on tau and Z. S is a set of stopping times, and Z is a class of treaties that we are considering. We can see that we also use here the dynamic principle approach, which derives in the Hamilton-Jacobi-Bellman equation. And here we have this different G from the last one, because this time we want to find the treaty insurance that maximizes the profits. So we also have the value function with the general solution here in the continuation region and the terminal value in the stopping region. We also need to admit that the value function is differentiable and continuous, so we use the smooth path conditions. And if you solve this, we have the solution given by a parameter A and X star, which is the revenue of the threshold of the revenue. And here we have the treaty insurance that maximizes the profits. So the company needs to choose the right time to invest, but also the right insurance treaty to buy. So for that, needs to know how to measure its risks and what premium is required. So first of all, the important thing is to measure these indirect costs. So for that, I use these three equations, the three functions. Then I use the three premium principles, the expected value, the variance, and standard deviation, and some insurance treaties like the proportional treaty, the one with a deductible, and one with a limit. So I have some examples because actually I mix everything to know which one is the best insurance treaty, or in each one, how much should the company insure. And I bring three examples. In the first one, I use this function, which is nu times EU squared. I use the premium principle of the expected value and the proportional treaty. So basically, if I pay hey, if the company pays hey, the insurer should pay 1 minus A. And in that case, we minimize the function G to have the optimal A. And actually, we found the value. So it is possible for the company to know how much should or not insure. Then I tried this function, the new times EU, the same premium principle, the expected value, and I changed for the treaty with the deductible. ZU is the risk retained by the company, and U minus ZU is the risk retained by the insurer. As you can see, ZU is also the minimum between U and M. And in this case, I did the same. I minimized the function in order to have the optimal M. And here we have two hypotheses. So if nu is bigger than alpha, then the minimum is 0, so it is optimal to insure everything. Or the opposite happens. So if the nu is smaller than alpha, then the minimum it will be 1, so it's optimal not to insure. Then I tried this one, which is the function nu times EU squared. This time I changed the premium principle to the variance, and I used a treaty with a limit. As I already said, the ZU is a risk retained by the company, and U minus ZU is a risk retained by the insurer. And I did the same as for the other examples. So I minimize the function G in order to have the optimal M. And that's the result, the equation. But it's a bit complexer this time. So in order to have some kind of solution about what should the company do, I tried to use an uniform distribution. And I figure out that if the nu is bigger than alpha, then the minimum will be 1. So it is optimal not to insure. But when the nu is smaller than alpha, actually we have a value for the minimum. And that means the company it's able to know how much should insure. There are other examples that I also tried, but it's harder to make analytically. So I put it on R and try to solve it numerically. And from now on, I would like to maybe try another functions or try to different premium principles, or even different treaties, like with an inferior limit and also with a superior limit, to see how the strategy of the company should change. And now it would be interesting also to maybe what to do if the occurrence increase and if it was necessary to reinforce the insurance, or maybe think about the insurer's point of view, if they have access to the company's optimal strategy, what they would do to gain money. So yeah, that's my next steps. And thank you all for your attention.
Thank you very much, Silvia, for your nice presentation. Now, questions to Silvia? No questions?
Can I ask a question myself?
Yes, of course. Go on.
Just one question. Maybe it's coming from my total ignorance on these matters, on investments. I'm sort of when you say that when you introduce a compound Poisson process in the model to model adverse events that are supposedly reducing the company's future revenue, what do you mean? So this compound Poisson process deals with the claims of the insurance that is attached to this portfolio, investment portfolio. Is that right?
Yes, because there are always jumps putting the revenue down. And we decided to formulate that as the Poisson process. Yes.
Yeah, but if you have if you introduce insurance, you have claims. That's why you have you have these steps downwards on your income. But on the other hand, you are receiving premium, right? And they are supposed to compensate and overcompensate the expected claims, aggregate claims, let's say, at least per period of time, right? So,
Yes.
so in fact, what the compound Poisson does is adding value to the portfolio, a positive value, or it is expected that it is adding value because insurance itself is a business, right? On their own. So it does not only bring, I mean, negative effects, but also brings positive effects, and those positive effects are given by the premiums themselves, right?
Yes.
So I don't think it is fully correct to say that 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 it is the compound Poisson. It's supposedly to model adverse events only, because there are also positive events. That's my question.
Okay,
That's
I'm
my
understanding.
point. Okay.
But in this case, it's putting down. But yeah, I understand.
Okay. Thank you.
Oh, okay. Any more questions? May I ask you, Silvia, if you tried different functions at the end that lead to different conclusions, but do you have, or do you may have in the future, real data from an insurance company to test the...
Yeah, I think that would be really interesting to try to maybe find real data and see how it goes.
Yes, to compare if the results are...
If it makes sense, yes.
Yes.
It would be really interesting to do that.
Okay. Thank you very much again. We'll still have 2 or 3 minutes to the next speaker, but I may present the next speaker. Thank you very much, Silvia. So the next speaker is Joana Rocha. She's doing her PhD at ISEG, supervised by Professor Alfredo Arcos and myself. And she's presenting this work. This is a joint work. I don't know if you can start 2 minutes earlier. Maybe
Yeah.
it's no problem.
Of course.
Okay.
Are you listening?
Joanna, yes.
Yes.
Yeah. So it's your time, Joanna. Go ahead.
So can you see my screen? No.
Yes. I can see the
okay.
screen. Yes.
No. So hello everyone. Thank you for being here. My name is Joana Rocha, and I'm here to present my doctorate program, which pretends to create a dynamic model to define optimal strategic assets allocation applied to insurance sector. I have been working in the insurance sector since 2012, and I'm working in the risk department since 2015. And this project pretends to help the company to increase the assets return from the investment perspective, but always taking in consideration the risk perspective. My supervisors are, as Professor Candida Mourão has said, are Professor Candida Mourão and Professor Alfredo Dirigio dos Reis. So this presentation starts with the work proposal, and after I will talk about the insurance business details and the model variables and restrictions. Starting with the work proposal. So the reason of this project is to help the insurance company to take best decisions on asset strategy. We want to improve the way the company manages the assets. And with this project, we pretend to answer these questions. How much to invest? what assets should we buy or should we sell? How much is the risk impact of buying or selling these assets? How much is the return of the new business and how much is the return of the new business with the existing business? How long should we invest? And if the new business complies with the investment limits. The purpose is to create an SAA model, strategic asset allocation model, to increase the expected return of the company and reduce or at least do not increase the SCR, solvency capital requirement. This model will have some constraints, some restrictions, and there will be the liquidity amount available, the investment limits defined by the insurance company, and the assets availability in the market. So the strategic assets allocation are one of the most important approaches on asset liability management, what we call the ALM. The goal of this project is to project multiple scenarios, several optimal mixes of assets for different return levels, which will be used as a guideline for a business investment strategy to achieve the maximum level of return given a specific risk level. So it helps the investment and risk committees of the company to decide the investment framework, for instance, the amount to invest, the percentage by type, by asset category, by rating, by maturity, and when to invest, based on the company risk appetite. And these committees, the investment and risk committees, will decide the most appropriate strategy to the company. So the SCR, this slide is a little bit to explain what is the solvency capital requirement. So Solvency II is a directive in European Union and in European Union law that establishes the European Union insurance regulation. It came into effect on January of 2016, and this regulation concerns the amount of capital that insurance companies in European Union must hold to reduce the risk of insolvency, and this amount is the solvency capital requirement. The SCR, the solvency capital requirement, is the economic capital that should be held to ensure that the insurance company can meet its obligations to policyholders or beneficiaries in order to have 99.5% confidence level. They could survive the most extreme expected loss over a 1-year horizon. So the objective is to calculate the solvency ratio, which must be bigger than 100%. That means if the solvency ratio is bigger than 100%, the company has enough own funds to cover this loss, what we call the solvency capital requirement. In last year, in end of year of 2020, the average solvency ratio in Portugal was 140%. So continue here with the risk models of SCR. The SCR incorporates risks such as market, health underwriting, life underwriting, non-life underwriting, counterparty default risks, and operational risks, and must be recalculated at least once per quarter. The yellow rectangles here shown with dotted lines are the SCR sub-risks which are directly affected by asset allocation. It means if we change the asset allocation, for instance, if we sell equity and buy bonds, we need to recalculate these risks to get the new SCR. So these will be the ones we need to pay more attention each time we need to change our asset allocation. So about the project, what is new in this project? On the one hand, we have the risk measure. This project pretends to consider the SCR as risk measure instead of the standard deviation. On the other hand, is a dynamic model adapted to insurance. Assets and liabilities may vary with market conditions. And the insurance sector has a particular meaning for ALM study, because in the insurance, the liabilities may change when the return of the assets increase, which doesn't happen in other sectors. And it happens because there are some products with profit sharing, which means when the return of some assets increase above a certain limit, the insurer needs to share part of the return with the customer, what we call the policyholder. So the methodology uses an optimization model and is being constructed in Microsoft Excel with VBA code. And the stochastic part will be built with another language. For instance, Python is an option. So with this project, we expect to achieve several asset allocation scenarios, allowing to increase the P&L of the company, the return of the company, and reduce or at least maintain the SCR, the risk level of the company. In the end, we will have an efficient frontier based on two measures. For one side is the asset return, and the other is the SCR. The market conditions will influence the results. For instance, government bonds do not have capital requirement. The spread charge on standard formula are 0, but with negative yields, like we have nowadays, the model, these assets do not generate enough return to cover, for instance, products with guaranteed rates. So the model will choose these assets to cover products without guaranteed rates. And this is just an example of how can the market conditions affect the model development. So regarding the business details, the insurance market has many lines of business with different characteristics. At the highest level are split in life and non-life business. Life is a long-term business and non-life is more short-term. This slide shows some examples of different lines of business. For instance, in life, there are capitalization products, retirement plans, life risk, and annuities. And the saving products, the capitalization and retirement plans, may have guaranteed capital, guaranteed rates, profit sharing, and so on, depending on the product features. And from the non-life perspective, the contracts or policies are 1 year horizon. And as example of lines of business, we have motor, property or household, workers' compensation, personal accidents, and medical expenses. All of these lines of businesses have different cash flow profiles. And for different cash flow profiles, we will have different investments. For instance, more short or more long-term assets with higher or lower return, with higher or lower risk level. And this explains why we need the asset allocation, an asset allocation for each portfolio and not for a company as a whole. We need to look portfolio by portfolio. So here we have an example of an LM cash flow profile. This slide allows us to see the huge difference between life and non-life business. The green bars are the assets cash flows during the next 50 years, and the yellow ones, the liability cash flows. The black line shows the liquidity at each moment, and the orange line is the accumulated liquidity. Life is a long-term business with longer liabilities, and so we will need to have longer assets with higher return to comply with the guaranteed rates of these products. There are some points with liquidity gaps, for instance, the second and third years here. The assets are not enough to cover the liabilities. You can see is when the black line is below 0. And in these cases, we will need to sell assets or keep the liquidity generated in the first year in a 1 year or 2 years investment to be able to cover these gaps. In non-life is a short-term business, so usually these portfolios didn't have liquidity issues. So continue with the model variable types and restrictions. So the model is building based on many variables. This slide shows the types of variables that we can have here in this model. So first we have the asset categories. We have cash, equity, real estate, corporate bonds by rating, government bonds by country, and at least the category loans and mortgages. The second type is the amount to invest. We need to decide how much to invest in each asset category, and this amount will be limited by the available liquidity on the moment. The third type is the year, the initial year of the investment. When should we decide to invest? And the last one is the maturity. In case of equity and real estate, the maturity is not decided in the beginning, but in case of risk-free investments or bonds or loans, the maturity is decided on the purchase moment. So in summary, the model is dynamic, and every year it will choose an asset mix to invest, how much to invest in each asset category, and what is the maturity for each purchase. The model also can decide to sell assets. If the liquidity is not enough to cover the liabilities, the model will decide to sell to cover the liquidity gap. And here in the end, we have the restrictions. The most significant restrictions will be the available liquidity. It means if in the majority of the years we have surplus, but we have some points when the black line is below zero in the chart. It means we do not have enough liquidity. So we need to sell assets on these moments or keep the liquidity coming from years before on short-term investments. So the companies also have internal investment limits, usually defined by board. And these limits are reviewed every year and it is established by asset category, by asset class, a minimum and a maximum. And in the end, we have the last restriction is the availability of the asset in a specific maturity in the market. For instance, this is a print of the Portuguese government bonds available yesterday. And in the last column, we can see that this class of assets is not available for all maturities. For instance, it's not possible to invest with 21 years maturity. We do not have 21 in the market. So we have two options. We can invest shorter, in this case, 16 years, or we need to choose another asset category to invest if you want an investment with 21 years maturity. And that's all.
Thank you very much, Joana, for your nice presentation. Now, time for questions. No question?
May I?
Yes, of course.
Thank you. Hello, Joanna.
Hello,
Nice to meet you here.
Yes.
I mean, just wondering, but I suppose it does. But the SCR, does it consider only next year's liquidity, or does it consider the solvency in terms of the present value of liabilities? And then does the model also take into account the impact of the change on interest rates on the present value of liabilities, especially for the life insurance products?
No, it considers the existing business, and in terms of new business, for instance, for non-life, it only considers the policies that will be renewal next month. It means they do not consider new business, just the ones which are guaranteed by the clients that do not cancel the policies before the moment. The other question is about life. So the life.
Yes, that if the model considers right the impact on the present value of liabilities.
Yes, it considers, but doesn't consider new business.
Right.
Okay, yes.
Okay, thank you. Any other question? Okay, so thank you again, Joana, and now you can, Alfredo, the next youngster.
Yes,
younger.
yes, that's another young speaker, but we are running ahead of
Yes.
schedule a little bit, so we have still almost 10 minutes to go. so that means more or less. Anyway, I don't know if I can start presenting our next speaker. Maybe I shall talk a little bit about Renata. Renata, she's speaking from across the Atlantic, down south. Well, north of, but South Atlantic anyway. She's Renata is now about to submit her PhD thesis in non-life. That's not life. But the work she will be presenting now is on life, or more said, shall I correct a little bit? I mean, it's more pensions like or subsidies, government pensions. She did a short work on some life stuff and pensions. It turned out to be a longer walk, almost a marathon anyway, but she's about to submit a thesis on non-life stuff. I mean, basically on ruin theory. She's been doing work with myself and sometimes with other people. And she will be talking about a specific existing public micropension program in Brazil. It was supposedly built to help very poor people. We found it was a quite interesting talk, less mathematical, but it was anyway interesting for the actuarial community. Maybe I should give the voice to Renata herself, and she can talk a little bit more about her and the work. Thank you, Renata. You can start whenever you like, even though we are running ahead of schedule, almost 8-9 minutes. Can you, Renata?
Okay. Hi, everyone. Yes, I'm here. Hello, everyone. I'm Renata Alcoforado, as Alfredo just said, and I'm about to submit my thesis. And this paper that I wrote, it's about a benefit that is from the national security system in Brazil. And it's going to be the intersection between the national security system and microinsurance. So this paper is on micropension, and the title is A Public Micropension Program in Brazil, Heterogeneity Among States and Setting Up of a Benefit Age Adjustment. I'm also from the Federal University of Pernambuco. I'm a professor in actuarial science, and that's why there is this name of universities here. So let's start. In a sum up of how this presentation will go, I will give a little bit of introduction on what I'm talking about, then a little bit of a literature review and background. And then I'm gonna tell you that this paper is divided in two parts. The first part, we wanted to see the impact that this program had on this system, but we also wanted to see what would impact this program. So the first part, I'm not gonna introduce it today. Basically, I'm not gonna present all of the things. I'm basically gonna say what we did there. And what I'm gonna get into and really present today, it's the second part. if you have any curiosity on knowing what it's on the first part, this paper is available on the archive. So you can always check it there or get in contact with me and talk. Okay, I'm gonna introduce the data here for both parts because it's two different data sets. Then I'm gonna talk about the impact on the INSS and this age adjustment benefit. We are gonna do this factor and adjust some things that I'm gonna say later and our conclusions. So let's start. In this map, I'm showing two countries, Brazil and Portugal, and why these two? Not only because these two countries are connected today, but also because this benefit that I'm gonna be talking about is available for people from these two countries. So for you to get an idea of how big Brazil is, because when we see this world map here, it's a bit not really their actual size. So we see Brazil here and we don't have the idea that Brazil is bigger than Europe. So in this map that Alfredo loves it, you can see all of the countries from Europe inside Brazil. And the best part is that you can see that Portugal and Spain are so tight together that even in here, they can stay together. And continuing, it's, as I said, the 5th largest country in the world. The population is for 210 million people and counting. The HHD, that it's the Human Development Index, it's a 0.759, that it means that it's a high one. But on the other hand, Brazil is the 9th most unequal country in the world. And a special concern should be put on the data distribution tail, and particularly on the left tail, on the poor side of the population. So some motivation for this paper is that due to the income inequality, this HHD, it's not reflected on a significant portion of the population. And the low-income people, they need to be protected since they live in risk environments and they're more likely to suffer during a crisis. And this microinsurance from the state has a positive impact on the entire family of the eligible citizen, and it truly impacts on the economic part of some particular areas or cities. This is quite obvious. If these people, they were basically starving and they get this benefit, it's gonna have a positive impact on their family. And also it's gonna impact on some particular areas or cities. But which factors impact the number of people receiving this benefit? And also, what is the impact of this benefit on the public pension system? And also how each federal unit weights on it. Brazil, it's, as I said, a big country. It has 27 different federal units. So does every federal unit weights in the same way? Do they weight the same? Is it a bit unequal? Can we make it even? And is this inequality reflected on the policy value by beneficiary on the system? And also, is the system fair? And if not, can we make it fairer? So a lot of questions, as you can see, and we wanted to answer all of these questions in this paper. So the first part, it's gonna comprehend until here, which factor impacts. And I can even tell in the end, if you want, which factors impacted the most and were statistically significant. But in this part, the second part that I'm gonna show today, I'm gonna show you what's the impact of this benefit on the system and also the inequality that we find in Brazil if they are reflected by beneficiary, by their federal unit that they reside. And also we are gonna see that actually the system is not fair. So we will try to make it better. So as I said, our object of study is the public pension system, more specifically on how the Brazilian National Social Security Institute, that it's INSS, that means Instituto Nacional de Segurança Social, deals with low-income people that did not achieve the necessary reserve amount to get a regular pension. And the conditions to get this pension is the person must have an income of less than a quarter of the Brazilian minimum monthly wage. So it's a quarter of 954 reais. And this means earning less than $61 a month. That means $2 per day approximately. And as well as being either over 65 or considered disabled. So as you can see, this program that we are talking here, it's really for people that only earn up to $2 per day. So in the first part, as I said, we aim to see how the following explanatory variables, that it's the HDI, nominal monthly income per capita, life expectancy at birth, and demographic densities, impacts on the ratio between the number of beneficiaries, there are 3 groups, and the population of its respective federal unit. The 3 groups that I said, it's the total group of beneficiaries, the elderly, and the disabled, and we compare all existing 27 federal units in Brazil. The second part, we aim to analyze the impact of social protection to the elderly and the disabled on the Brazilian National Social Security System. And to achieve that, we separate the beneficiaries by federal states and also by gender, since women and men, they have different life expectations. And also we focus on calculating the policy value of the protection to the elderly and how to improve the system fairness. And for this, we use both life expectancy at 65 and also at birth. So a little bit of the literature review. As I said in the beginning, we are talking about how the Social Security meets microinsurance. And when they meet, this intersection is called the continuous provision benefit in Brazil. That it's this program that I have been talking about. So a little bit of history. The INSS was created in 1990, and it was through the decree number 99,350. As a result of the merger of the Institute of Financial Administration of Social Security and Assistance with the National Institute of Social Security, as an autarky linked to the Ministry of Social Security and Social Assistance. The INSS is responsible for the operationalization of the recognition of the rights of the insured persons of the general social security system. And it covers more than 50 million policyholders and approximately 33 million beneficiaries. This data was from 2017. And the article number 201 of the Brazilian Federal Constitution observes the organization of the RGPS, which is a contributory and compulsory affiliation, where all the INSS activities fit in, respecting government policies and strategies for hierarchically superior bodies such as ministries. And the entity is currently linked to the Ministry of Economy. But let me just say a little bit. These policyholders are people that contributed to this general social security system, and they achieved the right to get the real pension. And these beneficiaries are people that they didn't get this right. They are getting some benefit. So it can be this benefit, but it can also be other benefits. A person might have suffered an accident and they can't work, so they are getting a benefit from the state. Women, when they get pregnant and they have their like a little bit of, it's like 3 months away from work, and this salary is paid also as a benefit. So all of these people receiving it are considered beneficiaries. And people that are receiving because they were every month paying for the minimum of 15 years and they got the right to get their pension, they are called policyholders. So the microinsurance, it's that we are talking here. It's basically the definition. I brought the definition from Churchill. And he says that poor households often have informal means to manage risks, but informal coping strategies generally provide insufficient protection. And the microinsurance is exactly this protection of low-income people against perils and cover a variety of different risks. And from the perspective of the social protection, we have that microinsurance schemes may assume some social protection functions, such as redistribution through internal cross subsidiaries or by channeling public subsidies to their members. And this BPC that I'm talking about, it's the organic law of social assistance. It's the guarantee of a minimum monthly wage for the disabled person and for the elderly that is 65 years old or older, who prove that they do not have the means to provide their own maintenance, nor by his family, and who can apply Brazilians or Portuguese that reside in Brazil. And that's why when I first showed the world map, I had these 2 countries highlighted. When we see, as I said, we have 2 different sets of data, and I'm going to introduce them both. In this, for the part 1, we use the data consisting on the total population of people that receive this specific benefit. So this data consists on 4,644,698 people, from which over 2.5 million are disabled and over 2 million are elderlies. In this part, we did some model and we were able to find that 2 variables were important, and those were the expectancy of life and also the HDI of the federal unit. For the second part, we saw that there was a high inequality in Brazil in this first part. So after that, we did some cluster analysis. And after that, we started with the second part. That's where I'm going to focus today. On the second part, the data that we analyzed consists on Brazilians that started to receive pension from the INSS on the period from the 2nd in January from 2018 until the 6th of April in 2018. And we also used the filter to separate the beneficiaries that belong to the group mentioned before, that is, people that receive the benefit called Amparo Social ao Idoso and Amparo Social à Pessoa Portadora de Deficiência, which means social support to the elderly and social support for disabled person, respectively. And the total in here consists on 1,332,000 people. And these people received this support are 81,000 and 40,000 are elderly and 41,000 are disabled. So in the first case, we have the total population and we have everybody, but we don't have the individualized data. And in the second part, we have 1 million people. And in this case, we have a completely individualized data. So we see their age, we see every kind of information that you can think of, we have. And after removing the elderly and the disabled group from those, we have 40,000 and 41,000 respectively for elderly and disabled, and their age distribution are presented here. So we can see also that this maximum here, it was a person that was 106 years old, and that's the age that he applied and was granted the benefit. So for the elderly, we have a minimum of 65 because it's the minimum age to be able to apply for the benefit. And for the disabled, we have 0 because it's basically a baby that was born with some kind of deficiency. And when we see it separated by men and women, we see that for the elderly, we have more women, for the disabled, more men, and in the total, we have 50-50. And now, calculating the expected discounted benefit, we have B as the minimum monthly wage, C of IJKL, it's the estimate for the present value of the benefit cost by UFI, sex J, in time K for individual L, in T is represented in months. And for simplification, we consider that if a beneficiary does not live a full month, the benefit's not paid, since the benefits are paid at the end of each month. It's on the 28th or 29th of each month. It depends and it changes every month. And let R be the monthly equivalent discount rate. And we used 6% here because of the inflation in Brazil at the time that we were studying this. And NY, it's the number of beneficiaries of UFI. And LE, it's the life expectancy in UFI for sex J. So we are gonna have 54 different life expectancies. And we defined the LT as the expected lifetime of the individual I, L in UFI for sex J, in exceeding months after a reference date. We use the date here as the 6th of April, because it was the last day of the granting benefit in our sample. And this way, we guarantee that all of the individuals in our sample are already receiving this benefit. And for instance, if the life expectancy is 64 for a person, and the granting age is 65 years and 2 months on here in April, then this LT is gonna be 46 months. And let N be the number of beneficiaries in our sample. In another way, let's consider also that N is the sum of MI1 and MI2, separated by gender, considering 1 for male and 2 for female. And following a similar notation, we also get that MJ is this sum as the number of people of sex J in the whole country. Then we have this total here, and that's how we calculated the expected discounted benefit. So we have the C here and this beats the benefit, and then we divide it by the time, by the rate here, and then we have, when we consider the sex, the UFI and sex J, and it's clear that the present value of all benefits, it's represented here until the LT. And C is the present value of all benefits. And this A here, it's the standard formula for the temporary unit payment with term N and discount rate R. So for the whole Brazil, we have that this total C here, it's this sum. We use the exchanged rate from the day of the 4th of April in 2019 that made €1 correspond to €4.35. And this exchange rate now in April in 2021 was 1 for €6.53. So in here we see all of the expected discounted benefit by UF, and we can see that it's really different, but we cannot talk like this. So we consider always the ratios, as I said. When we consider the expected discounted benefit in euros, we can see here considering the life expectancy at birth and the life expectancy at 65, because the person has to be at least 65 to apply. So when we consider at 65, we see that women, they comprehend 73%. And we can see this huge gap in the life expectancy. When we see for the male group, something is really important to highlight. It's that when we see the male group, we see here the highest, the UF, that the person, the beneficiary there, has the, gets more, has a higher expected discount benefit. For one beneficiary, it's Santa Catarina, and we can see that it's 15,000 euros. One thing that I like to show also, it's Brazil here, the average for Brazil, and in here we have Rio de Janeiro. For the male group, it's above average. When we consider the female group, Rio de Janeiro, it's up there. And here's the average for Brazil. And I showed you that the top one for male was Santa Catarina, that had 15,000. And Maranhão, that it's the bottom one for the female group, it's already 16,000. So the women, or the woman, the beneficiary, that it's a female, on the UF that costs less, the less, for the system already costs more than the male that costs the most. And here it's how we did the aging adjusting factors. Basically, we saw that these expected discounted benefits were completely uneven and unequal. So we calculated this age adjusting benefit factor that it's multiplied by 65. And we did two proposals. The first one, we proposed them separating by gender, and the second one, we don't separate by gender. So in our first proposal, this would be the new age to enter the benefit, and the age would go from 57 until 63. And for the women, the age would go from 64 until 67. The reason why we got in here we show for the male and the female, and the reason why we show this second proposal is that it would not really sit well if we would say that the women would start getting when they're even older, since for pensions, women get when they're younger. So we proposed this first one here and then the second one. And in the second one, we don't divide by gender, and this would be the new age. So when we see here, Rio de Janeiro would be almost as the average for Brazil when we put the genders together. And this happens because the gap in the life expectancy in Rio from male to female, it's over 8 years, and that's a lot. And this would be in the map, we would see here how it would be this factor. The higher factor would be darker and the lower one would be in a lighter color. And in this condition would be the same one as before, but then we would change the age from 65 to this age adjusting factor to. And the second one would be in function only of the UF of residents. And when we compared what we proposed to what they were proposing on the Social Security reform in Brazil, it's that they basically said, let's raise everybody up to 70, so 70 years old. And in here, I basically compared the life expectancy at 70 and the states and different federal units in Brazil. So we can see here that some states are okay, they would receive it for 4 years, that it's Santa Catarina, but these ones here, that it's Alagoas, Maranhão, Pernambuco, Piauí, they would not even get to the age of the entry age. And some conclusions here, it's that we use these two different life expectancies. Clearly in Brazil, the biological age is different from the chronological one. For the analyzed sample, we had these over 1 million here using this discount rate. The female group requires 6% of the total amount of this when we consider the life expectancy at 65 and 75% when we consider the life expectancy at birth. And in some states, there is no expectation of getting benefit, not even for 1 year. In the male group, with the exception from Rio, the states on top are all from the south, southeast, and center west, and the bottom north and northeast. On the female group, we have above average the federal districts and south and southeast, and in the bottom are all of the federal units from north and northeast. And when we consider the entire group, with the exception of Mato Grosso, we have above average the UFs from south, southeast, and center west. We proposed 2 different age adjusting factors to balance this, and with the proposed reform of the public pension, in the states that are in need the most, the population would not, on average, live long enough to receive it. And it's necessary to ask the government to better protect the elderly living in these states, since they are less likely to cope during a crisis. So these are the references from what I presented. That's it. Thank you. If you have any question, I'm here to answer them.
Thank you very much, Renata. I let you speak longer than you were supposed to, because we had lots of time, because the previous speakers didn't use their time. So I let you speak, but still we have 5 minutes to go. So we have plenty of time for a few questions, for a couple of questions. If there is anyone who would like to ask questions, please do. If no one wants to ask questions, I would like to ask Renata, just for curiousness, can you tell the people why Rio de Janeiro, the state of Rio de Janeiro, is so it's so particular from the other states in the age, in retiring age for male and females? Can you have some? This is a bit speculative, but I think it's interesting to know.
Regarding some speculatives, as you mentioned, on my side, but there are many papers on that subject that also I agree with what they are saying. So it's not just a thought, it's something that has some base. The problem in Rio, it's the violence. So when you see on the TV, oh, in Brazil, someone died because the police invaded, blah, 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 blah. That's not Brazil, that's Rio. Rio, it's a case apart. It's a different story, completely different story. So in Rio, one of the really things that got to the point that this happened here and these results happened in my paper, and I found these results, it's that the female life expectancy, it's over 8 years higher than the male life expectancy. So for you to gather how much this means, let's just assume I was seeing a paper that was showing the gap in life expectancies in France, and they showed how big this gap was when you compared a person with low education level with a person from high education level working in office and having a really good life, and this one is poor and low education, and this gap would be 3 years. And in here I'm showing people that live in the same place and they can have the same education level, but just from being male to female, although living on the same place, they have an 8-year difference in this gap. So this is really enormous when you talk about life expectancies, because you are talking about the average of an entire population. when we consider the whole Brazil, we have also a really huge gap, but no other federal unit gets to this point of having this difference as in Rio de Janeiro.
Thank you, Renata. There is another thing that I would like to underline, and then now I must be quick because I only have 2 minutes to talk, is that this program was supposed to help the poor people in the poor states, federal units in Brazil. But what happens is in the poor states, a big and a significant part of the population that were supposed to be beneficiaries, they cannot, because they don't even get to the age of getting the benefit. So what happens is that the higher subsidies, the big amount of subsidies are going to the richer states where the life expectancy is higher than those states. So it's kind of counterproductive in the sense that the program is not well designed really to help people from the poor states, and it's actually helping more poor people still, but from the healthier states, which are states from the south and southwest, more south of Brazil, southeast of Brazil, and with the particular case of Rio de Janeiro. Thank you very much, Renata. If you don't have any further questions, I will stop here and I will be presenting our next speaker. Thank you. And our next speaker will be our last speaker. And the last speaker will be Elena Macedo. If I'm not mistaken, I have to recover the title again. Okay, Elena Azevedo. Azevedo Macedo, but it's signed as Azevedo. She's talking about cyber risk and is analyzing self-protection and the problem of prediction of claims in cyber risk for the purpose of cyber risk insurance. That was the case, the purpose of it. Although it deals with cyber risk, but does not fully studies the calculation of the insurance business on the cyber risk, because it does not calculate or estimate premium for that line of business. Still, it's very interesting to know a little bit about cyber risk. And the fact is, Alana is also a lecturer from the university, the Federal University of Ceará, which is in the northeast of Brazil. She's been working with myself and Agnieszka at ISEG in her PhD, and I will let Elena speak now. Thank you, Elena. Can you hear me?
Yes, thank you, Alfredo,
Thank you.
for the introduction. So my intention today is to discuss a little about cyber risk through an analysis of self-protection and the prediction of claims. As Alfredo said, I'm not going to deal with insurance protection, but security protection, security measures like antivirus or firewall. No premium calculation was made since the interest was to investigate the nature of the risk itself. Why not calculate premium? This is because a lack of information on the database. It's difficult to find cyber risk database today. So we try to work with this database in the best way possible. So this is the summary that will be my guide during the presentation. So let's get started. First, why Brazil? I live and work in Brazil, so I look for a database that could show how cyber risk is being managed here. In addition, in 2014, Brazil was ranked as #1 in the world for banking malware attacks, with nearly 100,000 compromised users. At least 75% of Brazilian internet users claims to have been victims of some form of cybercrime. Ponemon Institute allocates Brazil in the first position of the ranking of probability of data leakage. This probability of data leakage is 43%. This type of risk can generate substantial losses. It is of fundamental importance that companies do not underestimate but manage the cyber risk to which they are exposed, even if they do not fully recognize its nature. We try to answer these two questions. Does security protections help to prevent cyber attacks? It is possible to predict the occurrence of claims and to generate information about companies that may have higher cyber risks attacks. Our objective is to shed new light on cyber risk by measuring the difference on the number of claims of similar companies with and without security protection against cyber risk. We measure the difference on the number of claims of similar companies with and without security protection against cyber risk using a propensity score matching. And we develop a neural network system to predict the occurrence of claims. Our database came from the Brazilian Institute of Geography and Statistics, the main provider of that data and information in the country. A total of 16,725 companies were considered. Intuitively, we said that companies that did not present any type of security measures or that presented only firewall working together with antivirus software has a minimal cybersecurity protection. For companies that have adopted other security measures besides firewall and antivirus, we consider them as having an advanced protection. The first variable used in the data design was the number of security measures adopted by companies against cyber risk. And the second variable, the outcome variable, was the number of claims. In addition, our research presents another 16 statistically significant variables related to companies that use the internet in the period considered. All these variables were shown to be statistically significant by use of a logit model. Regarding the depart variable, the first one here, there is a negative effect. That is, companies that don't have an IT department are more likely to acquire security protection from cyber risk. All the other variables presented significance and a positive effect. Before I start the analysis, here we can see that companies with advanced security protections present higher average of claims than companies with minimal security protection. So you can see companies with advanced security protection present higher average of claims. This is a direct comparison without considering the individual characteristics of each company. The purpose of using propensity score in a matching algorithm in this work is to produce an unbiased causal effect using observational data regarding the acquisition of cyber risk security protection and its impact on the number of claims. Rosenbaum gives a definition of propensity score. It's a conditional probability of assignment to a particular treatment given some vector of observed covariates. Let X denote the vector of those covariates for a particular company, and let the binary variable capital T indicate whether the company was exposed, T equals 1. In our case, if the company will have advanced security protection, or unexposed, T equals 0. If the company has minimal security protection. The propensity score is the conditional probability of exposure given the vector X of covariates. The steps of analysis, how we use propensity score matching. First, we calculate propensity score. In our case, individual probabilities of acquiring security protection against cyber risk. These probabilities are obtained by estimating a logit model given by this formula. After that, we stratify the data into blocks according to the propensity score. We test the balance of each block to guarantee the minimal distance in the marginal distribution of the covariates. And we apply the stratify matching through the average treatment effect given by this formula here. If the result returns a positive value, which in our case was 0.047, it means that the expected value of number of claims is higher for companies who purchase security protection against cyber risk than for those that do not. As it is a research applied to several companies that individually may have hidden characteristics, therefore not studied, an information asymmetry problem may have resulted into the conclusion that greater security protection does not imply a lower number of cyber attacks. Why did this happen? Could be hidden characteristics. For example, a feature that was not covered in the research is whether the company has valuable information. Companies without valuable information for hackers are unlikely to become targets of cyber attacks. Consequently, they may tend to invest less in cybersecurity. Those who know that they face large risk are more likely to get self-protection. So this is the first part of the work. And now we follow regarding the prediction of claims, and we will talk about the neural network developed. To briefly define a neural network, we consider the definition of Gallen that stated that a neural network model consists of a set of computational units and a set of one-way data connection. We consider a feed-forward multi-layer perceptron neural network, as in figure 1. We supervise learning. A multi-layer neural network typically has 3 layers. The first is called the input layer. The last layer is the output layer. The layers in between the input and the output layers are called hidden layers. In our case, we use 2 hidden layers. So about our model structure. After some simulations, we set an extractor that was represented by the number of nodes of the input layer. We use the 16 explanatory variables. The number of hidden layers was 2. The number of neurons to be placed in the hidden layer. The first containing 48 neurons and the second 16 neurons. The number of neurons in the output layer. It's our outcome variable, which has a binary character if the company presented or not a cyber attack. The activation function was the hyperbolic tangent. Moving on, we have the training algorithm. The most popular used algorithm for this type of training is the backpropagation algorithm. The number of iterations of the algorithm was 6,000. The stopping criterion, the estimation of the mean square error below the 0.01 threshold. Starting weights randomly selected in the interval here. The learning rate was 0.01 and the moment term 0.5. We consider a confusion matrix to show the results of the neural network model. as you can see, the proportion of total agreement, that is the proportion of companies in the test set that were classified as having a claim, actually presenting a claim for the multi-layer perceptron was 86%. Regarding performance measures, sensitivity translate the test ability to identify a company that is experiencing cyber attack, and specificity translate the test ability to identify a company that does not suffer from cyber attack. Both the sensitivity and the specificity value show that the model proved to be quite efficient in classifying both positive and negative class, all above 85%. Performance measure versus iteration. Figure 2 shows the evolution of the value of the performance measure in relation to the increase in the number of iteration. These values increase with the increase in the number of iterations, reaching a level of stability after 6,000 iterations, not needing to perform a greater number of iterations since it will only mean more computational time. Concerning the variation of the learning rate and the value of the momentum, its influence in the rates of the performance measure was similar. As the learning rate and momentum values increase, the sensitivity rate also increase. Accuracy and specificity decrease, the latter with greater intensity. Several simulations were carried out until the best model was found to represent the problem under study. We can observe that there was a significant improvement in the results from the first and very inefficient. Here was the first simulation that we performed, and the accuracy result only in 57%. We can observe that there was a significant improvement because the best model, the accuracy result was 86%. Sensitivity and specificity also improved after a lot of simulations and different parameters that we use. About my final remarks, despite informal arguments that favor protection against cyber risk as a tool to improve network security, we observe that in the presence of advanced security protection against cyber risk, the incidence of claims is higher than if a minimal protection existed. The classification result using a MLP, neural network, trained with a backpropagation algorithm was very good, with 86% global hits. And the neural model proposed here can be conducted in an innovative way, has a supporting tool for the decision-making of insurers, aiming at useful response to risk management. Here, you can see some references of the work. And here I finish my presentation. Thank you very much.
Thank you, Alana, for your nice presentation. I was about to warn you about time, but it's finished now. Thank you. So it was completely unnecessary. It gave me a little more time, a little bit of time to not ask you a question. So not asking a question. So sorry. Please, will you please ask? You can ask questions if you like, any one of you. If not, I don't have really special questions here because I know this work very well. There are lots of things here that I would like the problem to have, but we really have to face the lack of information that we would like to have with this database. We are waiting for more information about concerning this database, but so far the pandemic closed the way to get information themselves. The information that was led to this database was very hard to get already without the pandemic situation, because Alana had to go to the federal capital herself.
No, I went to Rio de Janeiro.
To Rio de Janeiro, yes, not the capital. To Rio de Janeiro herself, and to consult, to get the data.
For it, and I
had for it. Yes.
Pay for it.
Yes, yes. Yeah. Thank you for that correction. Pay for it, and now because of the pandemic, that is not possible anymore. The only way to get information is ask themselves when they have time to get the information, and then to give the information by mail or by other way, by internet, online. But Alana cannot access the information herself. It's very complicated. She's been waiting for months for that.
Yeah. The problem is that for me to use the data, I have to go to Rio de Janeiro and enter in a room, that a secret room without internet, and they give me the access of the database. So I can only use the database in their secret room without internet. So now the institute is closed due to the pandemic. So we are waiting to reopen for me to go there again.
Yeah.
And after you can use the data to your work?
Yes.
You can show the data? No.
No. Alana?
No. And then when I use the database, I give them the results, and I only have the results. I don't have the database.
Yeah.
And they checked, because my data, it's not allowed to present minimum and maximum values.
Yes. Only percentage, maybe, no?
Yeah. Yeah. It's very restricted. So. Yeah. But was the only database that I found here in Brazil, and the database don't give information about severity of claims, so we do not perform premium calculation, and that I'm almost a hacker finding data, because there is a difficult.
You should be careful.
Yeah. But I'm just
But
kidding,
now it was possible to get another database.
Yeah, now I get another.
But that is for a different study. So we had to close this study here.
Yeah.
Okay.
This one. Thank you.
That is an interesting study.
Yes.
Thank you. Thank you.
Thank you very much, Alana.
So I think we are on time, and we finished our window of
our youngsters
linking actuarial science and operational research. It was
Thank you all.
Yeah, thank you all.
Thank you.
It was a very nice presentation. Thank you all.
I do also thank.
Okay. So you close.
So shall we close this?
Yes.
Yeah, I think we should close.
Okay. Thank you, everyone.
Okay, thank you.
Bye.
Thank you, everyone.
All the best for all.
Okay.
Thank you.
Bye.
Bye-bye.
Bye.